Why does evolution turn everything in the deep ocean into a monster? 6 kilometers down, the pressure crushes steel, and nearly 90% of creatures must glow just to survive in endless night. Down here, beauty warps into weapons. Hunger forges nightmares of flesh and bone. What forces shape a world where nothing looks like life as we know it? The answer begins as we descend. 6 kilometers beneath the surface, the laws of physics become a sculptor. Here, water presses in at 600 times the force of the air above, enough to shatter steel and silence any animal built for the world of light. Survival means surrendering rigidity. Bones thin, dissolve, or vanish entirely. The snailfish, reigning at the bottom of the Mariana Trench, is a study in soft defiance. A creature with skin like jelly, bones so delicate they bend rather than break, and flesh that shrugs off pressure that would crush a submarine. Its body is more water than muscle, a living ghost designed to yield, not resist. Deep-sea crabs and amphipods abandon the armor of their shallow cousins. Their shells thin and lose calcium, trading strength for flexibility. Rigid structures fail here. Even the swim bladder, a buoyancy organ in most fish, becomes a liability. Gas compresses and organs rupture. In the abyss, gas is replaced by fat and fluid, materials that cannot be squeezed into oblivion. But the real battle happens on the scale of molecules. Cell membranes, the fragile barriers of life, face collapse as pressure packs molecules tighter than nature intended. Surface-dwelling creatures build membranes from straight-laced lipids, but in the deep, these would jam and fail. Snailfish and hadal ctenophores engineer their membranes from curved plasmalogens, lipids bent just enough to keep the membrane fluid and alive, even as the ocean tries to crush it flat. This is Homo curvature adaptation, a molecular trick that lets life persist where physics says it should not. Inside every cell, another defense unfolds. Proteins buckle under pressure, their shapes warping, their functions lost. Deep-sea animals counter with chemistry, filling their tissues with trimethylamine N-oxide, called TMAO. This small molecule acts as a stabilizer, propping up proteins so they can keep working. The deeper the animal, the higher the TMAO concentration, rising in lockstep with the crushing force above. Genetics, too, bends to the abyss. Genes like PIK3CA, VCL, and SPHK2, crucial for sensing and responding to mechanical stress, show signs of relentless selection. They help cells adapt their skeletons from the inside out, letting them survive the squeeze. In the deep, evolution is not a slow drift, but a forced march. Every adaptation a negotiation with the weight of the world above. Bodies become soft and strange, not because the abyss is gentle, but because only the flexible survive. Light is both a weapon and a warning. Below 1,000 meters, sunlight is erased, leaving a darkness so complete that ordinary eyes are useless. Here, evolution turns photons into currency. In the twilight and midnight zones, up to 80% of visible creatures carry lights of their own, each pulse and flicker the product of chemistry more ancient than fire. The anglerfish is a master of this darkness. Its body is a silhouette, almost formless, but from its forehead grows a living lamp, a fleshy rod tipped with a cold blue glow. That lure is not made by the fish alone, but by colonies of symbiotic bacteria sealed inside a chamber called the esker. The bacteria, fed by the anglerfish, perform a luciferase and luciferin reaction. Oxygen and substrate combine, a photon is born, and the abyss briefly shines. The anglerfish waits, motionless, while its lure dances, mimicking the wriggle of a small, helpless animal. In a world where every meal is a risk, this is the perfect trap. Prey are drawn to the promise of light, only to vanish into a mouth lined with teeth that point inward. Here, beauty is a ruse, and hope is bait. The dragonfish takes the arms race further. It wields a secret color. Most deep-sea animals are blind to red, as those wavelengths are filtered out long before reaching the abyss. Yet the dragonfish can both emit and see far red light, around 700 nanometers, a private channel invisible to its prey. Specialized pigments in its eyes, some stolen from the breakdown of chlorophyll in its diet. Let it pierce the darkness with a vision no other hunter possesses. Its photophores, glowing faintly red, act as sniper scopes in the black. In this world, the ability to see what others cannot is the difference between hunger and survival. Some creatures choose another path. They vanish altogether. Glass squids, transparent jellyfish, and larval fish dissolve into the water, their bodies almost invisible. Even predators struggle to find them, lost in the haze. Red pigmentation, too, becomes a cloak, absorbing the last traces of blue light, rendering animals all but invisible until it is far too late. In the deep, the darkness is never empty. It is crowded with signals, traps, and illusions. Light becomes language and weapon, a currency traded by monsters that have learned to survive not by brute strength, but by mastering the very absence of day. Hunger is the deep's cruelest architect. Down here, food is a rumor. Months can pass without a single meal, and every encounter is a matter of life or death. Evolution answers starvation with anatomical extremes, bodies twisted by famine, built to exploit any chance, no matter how rare or grotesque. Nightmare. The gulper eel is hunger-made flesh. Its body tapers to a thin whip, but its head is a gaping horror. Ligaments and cartilage stretch the jaws into a living net, able to unhinge and engulf creatures larger than the eel itself. When prey finally drifts close, the mouth balloons open, swallowing water, fish, or squid whole. The stomach expands to match, distorting the eel's silhouette into something almost unrecognizable. In this world, opportunity is so rare that evolution has erased all limits. Eat now or die waiting. Fangs. Fang-toothed fish are forged in the same crucible. Their teeth are so large they cannot close their mouths. Each fang is anchored deep into the skull, sharpened to a point, ready to impale anything that comes near. In the abyss, there is no room for selectivity. These jaws are built for desperation, not precision. Every tooth is a gamble against starvation. Ambush. Buried beneath the sand, the bobbit worm waits with patient malice. Its body can reach 2 meters, but only its jaws break the surface, scissor-like blades, triggered by the faintest touch. When a fish passes overhead, the worm erupts in an instant, jaws snapping shut with such force that prey are sometimes sliced clean in half. Scientists have yet to measure the true speed of this strike, but its reputation is well earned. Here, even the sand hides monsters. Wager. Every adaptation is a wager against emptiness. In the deep, hunger does not just shape bodies, it rewrites the rules of what life can look like. Time in the deep ocean stretches and twists, moving at a pace that makes surface life seem frantic by comparison. In this cold, silent world, some creatures become echoes of prehistory. The frilled shark, with its eel-like body and rows of needle teeth, swims today much as it did 80 million years ago. Its design is so ancient that fossils from the Cretaceous period are nearly indistinguishable from living specimens. The frilled shark's slow metabolism and low reproductive rate are not flaws, but strategies, ways to endure in an environment where change comes rarely and food is always scarce. The coelacanth tells a similar story. Once thought extinct for 66 million years, this lobe-finned fish was pulled from the waters off South Africa in 1938. Its blue scales and strange, jointed fins, a living fossil from a vanished era. The coelacanth's lineage reaches back over 400 million years, surviving mass extinctions and continental drift, unchanged in the darkness, while the world above transformed. Its discovery stunned the scientific world, proof that the deep can preserve life in a kind of evolutionary stasis. Yet the abyss is not only a museum of the past. Around hydrothermal vents, cracks in the sea floor that spew mineral-rich water at scalding temperatures, new species arise at a pace rarely seen elsewhere. Here, life is shaped not by the slow erosion of time, but by bursts of chemical energy and isolation. Each vent is an island, a crucible where evolution runs both backward and forward, forging creatures that are both ancient and utterly new. In the deep, time is a double-edged force. It can freeze a body plan for millions of years, or drive the birth of monsters never seen before. Right now, over 80% of our oceans remain unexplored, an abyss deeper than any mapped frontier. As technology descends further, each new discovery rewrites what we consider possible. The true monsters of evolution aren't what we've already found. They are what still lurk, unseen, in the darkness below.